Welcome again to our first masterclass. And of course, that today we're going to talk about advanced red team operations, which is we're gonna kind of like just go through some Active Directory exploitation techniques, and but we're gonna do a little bit more than the basics. It's not going to be like some standard, like just go in and exploit it, get the root. We're just more kind of a look at how to completely live off the land, which is no hard drive. Like we're gonna completely load the shell into the memory, try to bypass the AVs and stuff, bypass the AMSI, and yeah. So that's kind of like a just pretty kind of a just quick agenda, which is it's going to be who am I, some introduction about the scenario, then we're going to do a deep dive, then we're going to end up with a question and answers. So a little bit about myself, which is I'm a global cybersecurity architect for Project Worldwide, and I'm also the co-founder and CTO of Iron Fist Labs. And that's a little bit about like my hobbies and stuff. I did a freestyle wrestling and a combat sambo. Played some garbage music sometimes in my studio, and building the cyber gadgets and stuff. And there's some credentials that I'm holding. And I do have CISSP, CCSP, some offensive security certs, some SANS certs, and blah, blah, blah. And yeah, so today we're going to do our exercise in the multi-forest game of Active Directory. There's basically like just bunch of machines in the lab. We're going to start with initial foothold, gain persistence, then laterally move inside of the network by like just pretty much doing like just, step-by-step tradecraft, how we're going to like basically bypass some detection mechanisms and so on and so forth. So, all right. What's actually... That's pretty much it about like just the presentation part of it. So let's dive in. So I'm gonna use the Pentimento Labs by Iron Fist, which let me quickly start the lab, then get started. So let's give it a like just few seconds, then we're ready to go. Actually, there's like a bunch of different. There's maybe the next session we can do the like a Welcome to Valhalla one. This one is another like a good multi-force, like a multi-machine, like a just lab. I love that one actually. There's basically a few parts in that Valhalla one. There's part 1, part 2, and part 3, which is the hardest one. Is a part 3 actually. All right, so our lab is active, and the initial IP actually I already know it, like it's just 192.68.56.21. Actually, let's go and let me just go into the full screen, and let's kind of just dive in and see what do we have as an initial foothold. So the first things first that you always kind of just need to do is every engagement basically start with Nmap, the port scanning, which we need to kind of just see what services and ports and possible kind of entry points that are available to us. Which in a real so since we do have just 2 hours, I will try to kind of just fast forward a lot of things. But the thing is like when you do like Nmap scanning, Of course, you need to kind of apply some different techniques. Like you need to use like randomize the IP addresses through the Amazon Security Web Gateway. You need to like do delays in between the like just port scans, just because more aggressive that you're gonna do like a port scanning is aggressive, and we all know it. Like if you're gonna just do like a multi-thread or like just Nmap scan and stuff, like it's definitely gonna raise some alerts about like, hey, uh, there's connections like a scanning activity happening from IP address XYZ and so on and so forth. But for the purpose of today, so since it's our own like just local environment, we're gonna actually do aggressive scanning for the time limitation. But in real world cases, you just need to be very delayed like approach. Like let's say like just do like just 10 of these ports of this IP address in a 1 minute, or like just delay it 10 ports per minute, 10 or 20 ports per minute and stuff like that. So we're gonna do Nmap SC. Do you guys want me to zoom in, or it's just good so far? Okay, cool. Nmap SC -v, and I usually kind of like to do the full port scan, but well, we can just for the beginning we can leave it off like this. Then it's typical SYN scan, and also in order to kind of bypass some ping and alive host checks and stuff, and I will add the PN and provide the IP address. And let's see what we're gonna end up with. And I also add the verbose output. I just like to kind of see what's really going on during the scanning. So there we go. We do have some Windows ports. Like just by looking at it, like we can just basically say that, okay, this one is definitely a Windows box. We do have some web application, some RPCs, SMB, RDP, and we do have some WinRM ports in there. And yeah, let's wait for the NSC kind of just conclude, then the script scanning concludes that, then we're gonna examine the output and see what we're gonna do. All right, let me actually this. All right, let's take a look at it. So just by looking at it, like we need to kind of create a mind map about, all right, which service that I need to attack. So over here, in order to kind of just go through the SMB and stuff, you need to have credential, which is we don't know any username, we don't know any password, and even the RDP one. So we do have a way to kind of brute force it, but the brute force is just not really kind of an optimal way to kind of just do it. Especially if we want to kind of just go the stealthy mode. That's definitely not the way that I would do. But from the fingerprint, we can just see we do have a net bias name. It's Web Academy Ninja.LAN, and yeah, that's kind of a name of the machine and stuff. But the biggest, or the just possible avenue that it looks like, it just usually is in that type of environment, unless if you don't know the password or anything, or if you don't want to brute force it, the HTTP, which is the web application that we can possibly kind of get our foothold in. So let's go ahead and put the IP address and see what the web application gives us. And I will also create I'll also create the folder for organizing our notes and files and stuff like that. I'm gonna name it APT. Okay, cool. So let's examine it. It's Academy Ninja.LAN. So I will create just note over here. Create create a empty document. I'm gonna name it no. Oops, notes. Whatever. So I'll kind of just basically save the that domain, which is that's usually the just, we can end up needing it in the future phases. That's a domain that we basically attacking right now. So Academy Ninja.land, basically, let's see what functions and stuff that are available to us so we can possibly exploit it or get advantage of. We can look at the about page, which is, over here we do have some image and nothing else. Contact. We do have some information over here, which I think that could be very useful, which is Olivia at Academy Ninja.land and Frank at Academy Ninja.land, which that looks like it just emails and usernames and stuff like that, which usually in the Active Directory or just in the companies that they basically put like first name dot last name at something, and those are like a first and last name, or in this case is a first name only. That's the usernames, which we could potentially like just brute force it or do some enumeration or whatever. But I will kind of just take these as a note. All right, I'll paste it in here. There you go. By the way, in the real world engagements, of course, you need to have NDA and stuff. You need to kind of have like not notes in a mouse pad or anything like that. You need to have like a professional report and just a little bit more organization. And there's a list of students which we do have some function here: search by name, order by first name, and stuff. It looks like it's a SQL type of thing. What's kind of if we're gonna do LOL, nothing pops up. It pops up something, and there's some details. Okay, first name, last name, team, and just when we're gonna just do this, like look at that. As a URL is just basically changed. It's like a get parameter has been used. So what I'm gonna do is like rather than like I would actually I would let the SQLMap do some automated scanning. If it's like a just simple one, a SQLMap will find it. If not, we might. It's like just it really depends on the SQL injection vulnerability. That if it's a second order SQL and stuff like that, usually SQLMap is just not going to help you out a lot. So you need to do a lot of manual work. But let's kind of just start with the regular SQLMap. I'm just gonna copy that, and I'm gonna use the SQLMap -u and put it into the quotes and paste our address, and let's fire it up. It's recommend the union test. Let's do yes. And it shows that the backend as a Sybase, yes. The level and risk values one. I would always like to just choose a little bit like, yeah, I would prefer to choose the level 3 and risk 2, but let's kind of just keep it like this for now and see what's the result is going to be. And yeah, like get parameter order by is vulnerable. You want to keep testing it? Yeah. Just for your information, when you're running that like just automated scans, use like for stealth purposes, you need to do like just two main things. First is the delay in between the requests, and the second thing is changing your user agent, because user agents usually that SQLMap and stuff like that, they have like they're using specific like just user agents like Perl or whatever, and it like just it has like a just specific fingerprints. I would completely avoid it by using like a just regular like a user regular user agent stuff like a Mozilla, Chrome, or whatever, in order to kind of how can I say, minimize the noise. So the get parameter order by is vulnerable. Do you want to keep testing the others? No, we don't need to. And some errors happen. The backend DBMS is not Kubrid. Okay, we need to increase the level. Level 3 and risk 2. Of course, since it has a session already been saved in there, let's do flush. Was it a flush session? Yeah, okay. So it will start basically from the scratch with the level 3 and risk 2. All right, it's recommended to perform the union test. Yes. All right. Looks like the Sybase. Do you want to skip? Yes. Yes. All right, let's wait for. All right, there we go. The parameter order by. That's for like a time-based blind. All right. All right, this one is a Microsoft SQL time-based blind injectable and with the stack queries. All right. Actually, after that, I believe that if it's a Microsoft SQL server, so there's two things and two possible avenues. If the SQL server is hosted on the like a just different machine, which from the diagram that I kind of just looked at it before, it looks like that's how it is. That means the web application itself is on the one machine and SQL service is on the different machine. So we can potentially kind of like do a little bit like just hopping from here and there. But yeah, let's see what's the result is going to be. Then possibly we can get the XPCMD shell, and when we're going to get the shell, the things are going to become a little bit easier. Then we can spin up some Mythic C2. That's what we're going to use today. We're going to create our custom payload for bypassing AMSI and basically running entirely on the memory. But let's see, why is internal server error? Oh, that's weird. Let's run it out one more time. Yes. 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 Let's see. Maybe it's a timed out. The actual SQLMap can be funky, but let's see why it's. We do have. All right. All right. We do have time-based blind injection over here, but why is like it just but it should be able to kind of find the Microsoft SQL pretty easily. But all right, let's see if we can just if we do have the procedure call xbcmd shell in here. Let's see, because it can be funky sometimes. Since it's like they're just intentionally vulnerable, I believe either we have the functionality built in, or we can enable the xbcmd shell. And actually, you know what? SQLMap automatically does it for us too, I believe. Order buys, do you want to keep testing the others? No, we don't need to. And of course, it errors. It looks like our session is being saved somehow. Let me just look at the documentation that how to completely remove it. Remove the session data from the SQLMap so it's not going to get confused. Let me see. There should be copy. Okay, it should be in the users folder. Let's do OSLH. It should be local somewhere. .local. Say that local, or I'm not seeing it. .local. Oh yeah, there we go. Share. That's SQLMap is here. Okay. Actually, you know what I'm going to do? Remove the local entirely. Then run that one more time. So it's not going to get, hopefully not going to get confused this time. If it will, we might need to change the level and risk. Yes. Yes, skip it. Yeah. And since I haven't done the just this one, I just want to kind of rather than prepared all of the commands and just run it. I would like you to kind of see the approach itself. Do you want to keep testing the others? No. This is just becoming annoying.
I use this flush session sometimes.
Yeah, I did that too, Nahid. But it looks like a flush session. Yeah, but I don't know why it's like when it comes to the backend DBMS, it just pretty much it hates it. It doesn't want to see it. Maybe we need to test the other DBMSs. Maybe it's not a Sybase. I don't know. I haven't done these boxes before. But this time I will. Do you want to skip Taylor? No, actually, let's kind of test for other databases too. Database like services. All right, let's let it run and see what we're going to end up with. Order by as well. Do you want to keep testing the others? Not this one. And of course, maybe we need to actually, you know what? I'm gonna do this. I'm gonna do flush OS shell, and I'm gonna do it with the batch. Maybe that one's gonna work out. And I like SQLMap, but sometimes I hate it too. The batch basically gonna go through everything, like just basically apply to the defaults to all of these questions that it's already been asking. And of course, it is like giving us a hard time. Let's get rid of. I'm trying to kind of get rid of like the manual stuff that we did, and let the SQL map automatically decide everything. Maybe that one is going to work out. Because if we're going to end up like just doing the manual, like just work, that's going to take a very long time. And of course, it just drives me nuts right now. Okay.
What if we increase the level to 5?
What? I'm sorry.
The level.
Yeah, we like that's the last resort that I'm thinking. To increase the level to the maximum level. What's the level 5? Risk 3. Powershell batch. That's gonna be very slow, Alex.
Is it the only one endpoint selected?
I barely hear you, man. I barely hear you. Can you say it again?
Is it the only one endpoint?
Is it the only endpoint?
Yeah, the endpoint.
And this is just what's given under the lab, that this should be the machine that for entry point from the graph. But yeah, let's see. Let's see the level 5 is going to work out. Yeah, it just doesn't like us, man. It just it identifies the one that like so I'm wondering this is just identifies the the correct query, and it just identifies as injectable. But when it's testing for like a DBMS, what if we are manually with the DBMS value? I'm just thinking about like maybe that's the possible way to kind of pursue. I believe in SQLMap we do have DBMS equals MS SQL. Maybe we can manually, let's actually, since it's gonna be very slow, I don't want to kind of just do it this way, but rather than that, I'll do flush session, because it doesn't look like the level of risk, it just really really works out in this way. But the problem is the SQL maps fingerprinting the database type. Let's see. And it's not Microsoft SQL. Okay, let's add a little bit more. OS shell, batch. I'm gonna do technique equals S. Then let's do level 5 and level equals 5 and risk equals 3. Maybe this way is gonna work out. Let's see. No. Hope we're not going to break the SQL service, actually. I don't want to restart the whole lab again. But let's see. The service is still running. I'm just wondering. Okay, yeah, it's still active. All right, order by is vulnerable. Okay, it looks like something is different going on. Oh yeah, there we go. This time works. And now it identified that it's backend SQL service, which is SQL Server 2019. So the thing that works is, I believe, technique S, and when we provide that manually, backend like it's a service type. And it looks like we already have XPCMD shell, and now we're getting, since it's like a time-based blind, we need to, it's just making like a request per second, basically. And it looks like we're getting our shell. So since we're waiting for the output, let's actually spin up our Mythic C2 and create our payload. We do have Mythic, and I'm gonna do sudo mythically command line interface, start our Mythic server. All right, let's wait for it. And let's see the output. Yes, it's still getting there. Perfect. By the way, I love, have you guys heard about a Mythic C2 framework before? Have you guys worked with it? What about Sliver? SLI. Yeah, that's very similar, like just, C2 frameworks. But I love Mythic just because Mythic is very modular. You can basically plug and play lots of things on top of it. And Mythic agents are really good. I really love it. And on top of everything, Basically, when you running the professional red team engagement, you basically need to host that into the cloud somewhere. And Mythic's Nginx, and you basically can just do very complex and like a legitimate looking like a just C2 server by using Mythic, and I personally use a Kubernetes and with Mythic containers. But I mean, it really kind of up to you. It's just you can configure and alter it however you want. And let's see. All right, it's becoming alive, and let's see, our shell is getting there too. Nice. And actually, in the next part, we're definitely gonna create our tradecraft with Visual Studio Code. All right. Let me just send out to here. All right, there we go. I'm gonna, you know what? I'm gonna create a new folder named Masterclass. Masterclass. Oops, my caps locks are not really listening to me. Open a folder. Let's do Masterclass. Can I open the folder itself? Okay, desktop, Masterclass, open it up. Okay, yes, I trust, and let's go ahead and create our payload.ps1. So, let's see, our shell is active right now. And let's do a very quick one, host name, in order to kind of just check if we're on the right path or not. Very simple command, host name. Let's see, it retrieves and L. Basically, that's going to be the name of the machine, SQL. All right. So since we do have it, let's create our payload. The first things first, since we do have, since like our lab is scalable and just, and it basically spun up in the cloud, it has its own IP, and we can log into the Mythic through here. Let's Mythic admin, but I don't know the password, but we can get the password by environment variables. Yeah, there we go. Copy it, and oops. All right, let's log in. There we go. So that's where the magic is going to happen. So the payload PS1, we need to come up with some type of a structure. And that structure is like, first we need to avoid touching the hard drive completely and bypass AMSI. Since we're going to run some PowerShell commands, we need to bypass AMSI as well. Actually, I already opened up this one. The AMSI.fail is the one of the most well-known, like the kind of it's like a website that has all of that payloads. I basically kind of love just using it. This one is like a basically obfuscated AMSI bypass. I'll basically kind of just copy it and put it in the beginning of our PowerShell script. Then I add a few different parts. The first part that I'm going to add, which is I'm just going to copy and paste through here, which is the add type. So the first part, this one is basically open up the new, like importing some DLLs and stuff. So for us to kind of create a remote process and basically create another process, a legitimate looking process like Notepad or whatever, and so on and so forth, by using the system Windows 32 API calls. Then we're going to basically create the shellcode with Mythic, then let that Mythic shellcode buffer that runs entirely inside of that specific remote process that we're going to create it on. And so over here, we're going to put the Mythic shellcode, which we're going to create it, which is, it's going to be something like this, like byte buffer or something like that. That's where our the parts of the bytes that's going to live equals to, let's put it, Mythic. And after that, we need to, of course, after just getting all of the bytes and stuff like that, we need to create the notepad or whatever, and so on and so forth. And I'm just gonna copy this part. This is just one of my favorite, simple, just bypass technique, which I have in the script already. Basically, it will start the process, notepad, then it will try to kind of get the memory pointer address of the notepad exe. Then it will basically copy all of that byte buffer, the bytes from the buffer inside of the notepad. So our shell basically, or C2 agent is going to live entirely inside of the notepad. Then after that, we can, of course, do persistence and so on and so forth. But yeah, for the beginning, this one is perfectly fine. And over here, but in here, we're going to create a payload, which is Apollo is the best one, I would say, when it comes to the Windows box. By the way, if you're going to do Mythic C2 agent feature matrix, there we go. You do have like a list of agents, which is based on the operating system that you're attacking and so on and so forth. You can basically see they have like Athena, Apollo, Appfel, and it does have some specific C2 profiles, which we're going to use HTTP today, but usually in the real world engagements, you need to use HTTPS, MTLS, or something like that to kind of bypass the fingerprinting and encrypt your whole traffic. And you also have the architectures that support it, which we're basically attacking the x86 space. But yeah, there's some stuff that can be ARM or whatever. So it's just really up to you. And that supported features is a really good one. And you can see Apollo has a lots of stuff that you can use for lateral movement. Like, for example, that I really like execute assembly one, execute P, which is, you're running that specific assemblies or .NET assemblies and stuff like that entirely on the memory without even touching the disk, which is really, really, really good for evasion. And it has in-memory mimikatz and stuff. But yeah, long story short, the poll is the one that we need to kind of definitely use. So we're going to start fresh using Apollo, and there's an output type, which is we can create the exe type, but we're not going to just do it, or service or source, but we're going to just get the shellcode. We don't need the debug version and shellcode options. It can be binary, but what we need is a PowerShell. It can be C# in case you're kind of compiling by yourself and stuff like that, if you have like some custom routines. But what we're going to do is a PowerShell. It has some donut shellcode functionality, which is bypassing AMSI or event tracing. But yeah, we can just, leave it like this. And that's where the magic stuff, which is we need all of those modules. You can basically choose. So these modules are individual components of an agent. You can basically, if you need like just, let's say like a module XYZ, you can just, basically include those ones, and your payload is going to be very small. But since we're kind of just adding a lot of modules, our payload is definitely going to be huge, actually. So, and we're going to use the HTTP, our C2 profile, which is the listening agent, basically. We're just basically telling the agent that, hey, that's your connect back address. And we're going to include that. And in a real world cases, you just need to have, like I said, that red team infrastructure in the cloud with the legitimate looking domain and so on and so forth. And the callback intervals and jitters are the bread and butter of it. Like, that's what I exactly mean that in the beginning, that the delays and being like not very noisy and aggressive is the key in stealthy engagements. That usually the red teamers put like 1 request per minute or 10 requests per hour or whatever. So it really depends on the your objectives. But since we do have a very limited time in the class, we're just gonna keep it like 0, which is actually, let's keep it at 10. Then we're gonna when we're gonna interact with the agent, we can just change it to 0. That means like a instant, always like just callbacks every second, pretty much. And the callback host, which we need to get our IP address, which is our IP is 192.56.74. Okay, I'm gonna copy that one and put it here. And I will, since we're in the local lab environment, I'm not even gonna use the HTTPS. So, but you need to use the HTTPS in the real world engagements for encryption. I would even use the MTLS, to be honest. That's the safest option. Mutual TLS connectivity. All right, so our payload is good, our host is good, pre-shared key it looks good, the callback port is 80. We don't have any proxy, so we can leave it off. Yeah, look good. And let's create the payload. And let's start the building. All right. While it's building, so do you have any questions so far? Okay. And actually, we can open up in here too, but whatever. All right. So we do have our shell in here. Let's download it to Masterclass, Apollo, and there we go. Let's take a look at this one. There we go. We do have a byte buffer in here. You see, this is basically, well, let's call it Apollo.ps1. We do have our byte. Our payload, and it's freaking 10 megabytes. And it's pretty huge, actually. Well, in the real world cases, you just need to kind of do staged, payloads like stage 1, stage 2, and so on and so forth. You cannot just basically throw it like it's all in once. And basically, we can start creating. Okay, there we go. We can write it here. We can basically build our prototype around it right now. And I'm gonna copy and paste the rest of the code that we talked about in the beginning. By the way, all of that codes and stuff are gonna be, and even the recording, gonna be available on the Iron Fist Labs. All of the commands that has been used and so on and so forth. So you can easily build it out by yourself in your home lab, and you can reproduce the attacks. And we're gonna paste the rest of it. There we go. It looks good now. And what I'm gonna do is I'm basically gonna send this payload to our Kala machine and try to execute it on the SQL server and see what's going to happen. All right, so we do have OS shell in here and the Mythic. Okay, now what I'm going to do, I'm going to go to our working folder where our notes and stuff in here. I'm going to use the very stupid way to kind of upload the document, the Apollo PS1 in here. LVNP 4444, and I'm gonna send that output to payload.ps1. And since the IP address, okay, I'm gonna open up my command line. All right. Masterclass. All right. I'm gonna basically do NC IP address 444 and send our, what was the name of the payload? Apollo.ps1. Yes. Apollo.ps1. Okay. Let's check it out. Yep, it's received. We do have payload.ps1. Let's take a look at it. Oh yeah, that's quite chunky. Now, it's the time for testing it out. Let's see if it's going to work. So what we're gonna do is since we do have a OS shell in here, I'm gonna do Powershell. No profile. Then basically what we're gonna do is we're gonna do no profile, execution bypass, and we're gonna use IEX new object NetWeb client to entirely run it on the memory. So we're gonna do Nmap, and we're gonna do window is, of course, it has to be hidden. And we're going to do execution policy bypass. Then we're going to run the command, which is IEX new object. And we're going to do a net.web client. Then we're going to close that one out. New object, net web client. Then we're going to do download string. And we're going to provide the address, which is HTTP. And we need to host it in here. I'm going to use python-m HTTP server. And we're going to host our payload in 8000. Then actually, what was our IP address? IP ADDR. Let's see. All right, this one. Right, then we're going to do HTTP and port 8000, and our payload name was payload.ps1. All right, payload.ps1, and then close it. Then, yeah, that should be it. Let's double check it. IEX, new object, net web client, download string, and our payload. Yeah, that should be good. So what we're doing over here is we're basically telling the hey, like PowerShell, get that, download that string and from that specific address and basically run it, which is what we have here is a PowerShell script anyways. And it will completely run on the memory. There's no hard drive interaction going to be at all. And in our PowerShell, which we already discussed, we do have, since this lab has like a just fully functional and updated Defender on it, we just need to bypass the AMSI since we're running the PowerShell. We don't want the Defender kind of flags it and stuff. And yeah, let's run it and wait for the responses and see what's going to happen. All right, let's see if there's active callbacks. Nothing yet. Oh, there we go. We do have an active agent now. We do have SQL User Academy. Great. Now we have our foothold in. Now it's a time for some lateral movement, that's what I love. But the first things first, let's interact with the agent. And usually what you need to do is you need to increase the sleep timer in the real world engagements. But this time, since we're doing some type of a lab and we don't care, and there's no one is watching us, there's no SOC member or anyone that basically monitoring our activities. So we're going to do sleep timer to 0 and jitter to 0 in order to kind of have instant callbacks. And you see, it was before like every 10 seconds, but it should be right now. It should be every second. So let's kind of just do LS, and the first things first I want to do is who am I, to see what the user context that I'm in, and we are Amphi Authority Network Service. What I'm usually doing when I get just initial foothold and stuff, I basically start, Vim piece. Have you guys heard about the Vim piece? WIN piece. Yeah, that's basically privilege escalation kind of a just checker. And also since it's a network service, anti-authority network service, our privilege escalation path is just really obvious in here. Since we do have SE impersonate privilege, we can use the rogue potato, sweet potato, or some type of a potatoes to get the system shell. The reason that we're trying to kind of achieve the system shell is we're still on the limited user. We're not we don't own the system yet. And when we're going to own the system, we can run the mimikatz and stuff and get entire just hashes. And if someone kind of logged in and so on and so forth, we can just get a little bit more deeper, how can I say, the picture about a system, and we can basically go wherever we want to. All right, so let's actually let's use some potatoes. Since we're in the system info, let's see. Do we have system info? No. Do you have any info? Let's see if we do have some get priv, get system, help, inject, inline assembly jobs. Okay. Whatever. We can basically do 1 second. Shell who am I? If that will work, we can do system shell system info. Okay. Shell system info. Let's see what kind of a version and stuff that we have. We do have 2019. So definitely sweet potato is the route to go. By the way, shell is basically when you run shell command in that C2 agent, basically it's a cmd.exe. That's what you're running. And yeah, I'm gonna basically oh yeah, it's still running, but we don't care about it, and we don't care about the SQL shell anymore. So we already in. There's a Flangovic, I believe Flangovic start collection. Yes, it does have like very good resources, already compiled, executables, which the one that I want to use is sweet potato, which let's see, where's that? Is there any sweet potato? Yeah, there we go. We're basically, I'm gonna download that sweet potato over here. And I'm gonna basically execute that assembly and see what's gonna happen. Actually, I'm gonna completely run everything in here. HTTPS. Just because my system, if I'm gonna download it to my Mac OS, this definitely, my antivirus definitely gonna remove it immediately. So we cannot. I mean, I'm gonna be unsuccessful, but that's why I'll just download it in here, then execute that from my Kali machine since it doesn't have any antivirus. All right. So I'm gonna do execute assembly. When we're doing execute assembly, it just completely runs entirely on the memory as well. Like we're not touching the hard drive at all. Then we need to put the new assembly, select the file. We can select the file from here, which is a sweet potato, and we can put some arguments. But before putting the arguments, I just want to kind of execute it and see if it really works. And there we go. All right, it definitely works, and it's just already kind of we can see that impersonation was successful and blah blah blah. It definitely ran, but the thing is, like, we need a different way. So usually what you're really kind of just need to do is like you basically create the process argument like, hey, sweet potato, basically after you're being successful, run the NT system shell, run this command as NT system shell or whatever. But since we kind of just, already kind of own the system, I will actually, our Apollo is the donut shellcode also, being heavily obfuscated. We can basically create another payload. Like executable, basically tell to sweet potato, hey, when you're successful, when you're in the system shell, just run the the C2 whatever exe. And I'm going to have this. Okay, that looks good. Polo.exe, let's create it, and the payloads. I don't need that anymore. All right, this one is ready. We download it, polo.exe. All right, since we do have the active callback, let's actually move to some directory that we can write to, cd users. Hold on a second. What? cd users. Okay. Let's see if we do have public. We do have public. The public folder, usually everyone has a read-write access to it. So we're going to upload our Apollo to there. But usually that's not the best way to do it, to be honest. Since we're touching the hard drive, whenever we're going to touch the hard drive, that's not a good way. But since we're we do have very less of a time, very little time left, I will basically upload it and do a little bit fast forwarding. But usually what you need to do is create the beacon object file, and basically that run your shell code inside of that beacon object file, and basically tell the sweet potato that when you're done, run that pipe, and it will give you like a just system shell. But we're talking about another like just 10-15 minutes there. But that's why I want to use our time a little bit more efficiently. And now for execute assembly, well, I'm gonna basically look at the sweet potatoes command line in here, which sweet potato. All right, let's see what it does. All right, Mom, by the way, in case you're wondering, I'm looking at this. It just looks for the value, and program value, which is the default one, is a CMD and arguments. So which I'm going to do is basically run the program, which is the -p, and provide the address of it. And yeah, I believe we should be good. Let's see. We're going to do execute assembly, which is the sweet potato, the arguments, which is -p, c, which we're going to do. Let's kind of put it inside of the column. C, users, public, polo.exe, which should give us the system shell. It's supposed to actually, but we'll see. All right. Oh, there we go. We do have a system shell. We do have a callback. Great. Now, since we do have the system shell, we're going to use a sleep 00. And now it's the time for some lateral movement. So the first things first, what I would love to do all the time is do mimikatz. Let's see if we do have the mimikatz functional. I'm going to do basic coffee. Can you guys see how powerful that, like, just, that framework is? Like, it just runs, Usually the defender, whenever sees the like a Mimikatz, it should cry immediately. But since we're on the entire line of memory, I mean, it basically runs whatever we want without triggering anything. All right, so since we do have the Mimikatz coffee, let's do secure LSA log on passwords and see what we're gonna get out of it. All right, it's still working. There we go. We do have our output. Nice. We do have some users with their NTLM hash. Let's see what else. We do have SQL's machines. Like, that's such a nasty long password, actually. But that's a clear text password of the machine account, which we don't really need it, actually. We need the NTLMs only. Let's see what else that we have in here. Yeah. But so far, we do have the Frank's NTLM hashes, which is very good. And now, since we're in, I also want to use Sharphound, which is in the Active Directory environment. Bloodhound is your biggest resource to map out like where you need to go and stuff like that, and which object or user that you're attacking the next. So I'm gonna quickly download the Sharphound. Sharphound. That should be it. And releases. And let me just. This one is a pre-release version. I don't want to use that. Yeah, I'll use the 2.90. Okay. We just need this one. And open it up, Sharphound.exe. I'm going to put it to our apt folder. Okay, now we have it. All right. Since we do have the Sharphound right now, I'm going to go ahead and execute assembly again, but this time I'm going to use Sharphound. It should be in our desktop, apt Sharphound.exe. And arguments, which Sharphound, you just need to, this is the most effective one. See all means I could just grab everything that you can. That's command line argument that we need to put. And let's task it. And let's see what's gonna get. All right, it's waiting for the assembly to finish. All right, there we go. We do have all of our results and saved in the user's public. Why I cannot ls? Okay, we do have it in here. And what I'm going to do is, instead of using the Bloodhound in my Kala machine, which I don't like it, because it can be, that Neo4j can be very heavy and can be very slow. That's why my Mac is pretty powerful. So I do have my Bloodhound in my Docker. So what I'm going to go ahead and do is I'm going to run the Bloodhound in my local in my Mac. It's way faster. All right, we do have a Bloodhound in here, and let's open it up. It should be admin and password. I don't know. What was the password? It should be, oh dang. All right. You know what I'm gonna do actually, since I don't know the password on top of my head, I'm gonna I'm gonna basically rebuild uh, the whole Bloodhound. Bloodhound. Where's the Bloodhound? Bloodhound. All right. What I'm doing is examples, Docker compose. What I'm gonna do? Docker compose down. All right, and then I'm gonna do up again to rebuild the whole stuff. Then it should give me initial password. Ready? Do I have a password? No? How come?
I think I have seen it.
What? It should have an initial password somewhere, but 1 sec. Let's see, maybe the volumes is there. That's why it, oh yeah, Neo4j data, of course. Let's see, Docker compose Postgres data, and I'm gonna delete all of them. And let me just build it again. Change the password. Okay. Change the password for Neo4j. Setting up the password. Change me. Okay. There we go. Initial password. There we go. That's what we need. And I'm gonna go ahead and log into Bloodhound. Then that's where we need to upload our zip. But before doing that, I'm gonna, where's our Sharphound? Okay, I don't know. Let's kind of do this, ls, and I need to download this one, download. All right, we do have the file itself, then we can download it to our Masterclass folder. And now we can start to do some bloodhounding. All right, let's do upload, close, and let's watch out if it's complete. It's now ingesting, analyzing, then complete. Nice. So now let's look at one by one. So now we own the SQL machine. We can add it to owned and see what kind of specific misconfigurations that we can possibly abuse. Let's see, we do have some sessions, which is Frank has a session. We already got the Frank's, we can add it to owned as well. We already have his NTLM hash. And let's go back and just see what's more out here. There's local admins, which is Yara, David, and Frank. Frank is actually part of the teacher. We might kind of possibly need to look at it too. As admin to here. All right. What else that we have? We're just trying to get basic information that about the system itself. And we do have inbound execution privileges, and we do have SQL admin users. Oh yeah, that SQL service user has SQL admin role in here. Okay. And we do have inbound object control we don't care about. We mostly care about the outbound. Okay. Oh, that's pretty good. So the generic that's what we can possibly abuse, which is SQL Academy.ninja, that our machine has generic all privilege on computers at academy.ninja.land. That means we can add the computer objects to this container and possibly get the service ticket and abuse and laterally move to the different computers as well. But let's kind of just, look at the Frank as well. Let's see what Frank is able to do. So Frank basically has, it has 2 sessions. It has session on SQL and it has session on web. That means without even without even just doing the generic call on the different computer, which is the web in this case, we can basically use the Frank's NTLM hash to dive into the webacademy.lan. And Frank is a member of teachers. Okay, what else? Local admin privileges. He has local admin on SQL. Okay. He has execution privileges. And he also has constrained delegation privilege to share academy.lan. So this user has a good amount of it just lets us do lateral move 2 computers right now. One is share, another one is web. And we don't care about the inbound one just because inbound just shows who has rights and stuff like that and Frank. But let's actually move to the web first. Let's own that machine as well. In order to do that, we need to find out web's IP address. But usually what you need to do is a proxy chaining, but since we're already inside of the, our lab, we don't really need to do that. But in the real world case scenarios, you definitely need to do proxy chains. But let's find out shell ping -c for web. Let's see the IP address. Web. All right, 21, but it doesn't reach out. Maybe there's an internal firewall that blocking it. The pings, we don't know, but we can, since we do have the IP address, we can basically see what we can possibly do is we can do netexec, which is it's basically crack map exec. Have you guys heard about crack map exec? This one is decommissioned. I mean, it's end of life. netexec is still being supported by a few developers, so it's most up to date one. I'm gonna do 192.168.56.21. I mean, 21 is a web service. I believe we should be fine in there. All right. Now we can use the Frank and the Frank's hash, which is we already have in here. Okay, Mimicat secure LSA. What was the password? Oops, I guess I went too far. All right, is NTLM hash is this one. Copy, and I'm gonna use it in here. Let's see what we have. All right, pond. We do have a full admin. When it kind of just when the netexec says pond, that means we're fully on the system. All right, since we know there's a WinRM service in there, you know what I would love to do is I will use Evil-WinRM to move to the machine with and get the shell on that there too, and run the agent. Username is Frank and hash is we're gonna put that one in there too. Let's see. All right, we're right back in. And since we do have our PowerShell one-liner, I'm gonna go ahead and run our PowerShell here and paste it. Let's see what's gonna happen. All right, it's thinking. Let's see. All right, there we go. We do have, we own the web as well. Nice. So since we own the web, actually we can do sleep 00 in here. And we can basically do get system since the Frank has a local admin. The get system command, it's like if you guys familiar with the Metasploit framework, it's pretty much the same thing. It's using it's basically looking at the privileges and see like which one that it can easily abuse. And yeah, we're a system. We're gonna look at the get privs. And yes, we do have, and currently, one second, I just want to see the context. Okay, impersonation. All right, we're good. Actually, we can add that into our Bloodhound as well, that our web machine is fully owned. And let's see, is there an outbound object? No, there's no outbound, no nothing. Basically, it's kind of like a dead machine in there, kind of like that. But what we can possibly do is like I would still run the Mimikatz and see if there's any other credentials that I can possibly get. Secure LSA, log on passwords. All right, let's see. Oh, I might need to do a privilege debug, actually. Let's see. We do have Frank, which we already knew it. Let's see what else that we can get out of it. We do have the machine account. We don't need that. And what else? It's a machine account, basically. Do we have anything else? Nope, it doesn't look like it. Yeah. So yeah, so we own this one, but we also saw the Frank has another privilege, which is it has constrained delegation on share. If we're going to click on here, we can see how we can possibly abuse it. So basically with the get st, we can basically create some type of a ticket in Kerberos service, and we actually, log ourselves in as, to that share as some type of a user. We can impersonate and stuff like that. But the first things first, we need to know which service that we are allowed to delegate to. Then after that, we can basically do some hopping to the share. In order to kind of just do that, since we do have like a Frank's hash and stuff, but we first need to find out the DC's address, which I'm gonna do shell ping DC. Should be actually, I saw it somewhere. It should be 20. Was it 20 shell ping? 1 second. I believe it was 20. Let me just exit that one. We don't need it anymore. It was, I believe, 20, but let me just double check. Oh, no, not Evil-WinRM. Oh, God damn it. Let me refresh my page, actually. I need to. Come on. Come on. We don't need you. All right. I'm going to do 20 and see if that's a DC. All right, there we go. We do have DC AC, which is our domain controller is at 20, and we need to that's where we need to kind of request a ticket, basically. So yeah, let's start to kind of use the in packet to first identify what kind of a service that available to us. Then after knowing that which possible service that we're allowed to delegate, then we can basically use a workaround for that. So what I'm gonna go ahead and do is, what was the command for? I'm just wondering. There should be in packet. In packets like delegation. 1 second. In packet. Search delegation. Should be something like that. Oh, find delegation, actually. Yes, I completely forgot about it. So we're going to use in packet, find delegation. Then we're going to basically provide the domain, domain name, user, hash, and basically DCIP as well. Let's do it. Our domain is academyninja.lan. And let's put it in here. And our username is Frank. And we need to provide the hashes. And our hash is this. And then we need to provide the DCIP, which is the domain controller IP that we're requesting as 192.168.56.20. Let's find it out. And we do have error, of course. What was there? It just basically asking for, so we need to provide LM hash and NT hash, which is, LM hash is, you guys know that, right? LM hash is not really important it's just kind of like a freaking placeholder, which we can basically say that LM hash is this, even like it's a bullcrap. The Kerberos doesn't care about it, so we just need to put like the format itself. So we added like a formatted version of it, and let's see. There we go. We do have constrained delegation as event share. We do have a delegation rights to event share. That's where we need to kind of put it as an alternative service. Then we can impersonate whoever we want to. And yeah, let's go ahead and do it. And we're going to use the in packet get service ticket. Get service ticket. Then we're going to provide the SPN, which is event log share. And there we go. Actually, in packet is very, very finicky about the commas and some special characters. So I'm going to put everything into the double quotes. And we're going to provide the impersonate, which is who we want to impersonate. and we want to impersonate admin administrator actually, then we need to provide the alternative service, and which I would always love to use is CIFS, just because if we're gonna just have the CIFS CIFS, we can possibly do PS exec and SMB exec on top of it too. So that's kind of an easy win. So we're gonna do CIFS share, then DCIP is 192.168.56.20, and here then we need to provide academy.ninja.lan, and basically our user is Frank, and our hash is NTLM, and let's see what we're gonna get. All right, let's see. All right, we do have ticket in here. Now, it's a funny part is like we need to export it. Export, I believe it should be Kerberos 5cc name. I don't know. And equals to admin. Okay. Now we can do some work like a PS exec or secret stomp or whatever we want. If we're admin, we should be able to do secret stomp and PS exec. And let's do impact at secret stomp. We can do add share, which dash K, dash no pass. Since we're going to use we already exported that as an environment variable, impact automatically kind of picks it up. And let's see, 192. What was the shares IP actually? We never kind of shell ping share. 23. Okay. So we can 192.168.56.23, and let's see. All right. No arguments. Yeah, of course. Target IP. Target IP. And what did I make? Oh, I made a typo. Let's do target IP. Come on. Can you? There we go. Yeah, we do have full privileges. Nice. And actually, that's interesting. We do have a GMSA too. Oh, 1 second. Let me just take a look at the Bloodhound, because that GMSA can be a good one. Outbound. Oh yeah. We can, with the GMSA, since we have the hash of it, or we can actually get the hash of it, we can change the password of backup. And backup, let's see what backup has. Oh, look at that, guys. This is just basically the way to go. Actually, I can just see it right now. Backup has right owner of admins, backup operators, all of them are like crown jewels, that's definitely the way to go. What time is it? 11:45. All right, I need to stop in here actually for Q&A. But yeah, that's where the path goes on to. Most probably after we own the DC, which was DCAC, I'm pretty sure it has the it has Academy Ninja.lan. Academy that it has the like trust forest like it's a forested environment. I believe it has like a bidirectional trust. Yeah. Then from here we can just move to like a ninja and blah blah blah. But yeah, I mean the time is very limited, so I need to kind of just stop right over here. So